Z-scores to somebody mean absolutely nothing. Usually standard deviation doesn't mean a whole lot of anything. What they want to know is, where's my cutoff? What number is my go-to number? What am I looking at? That's what they want, bottom line. Like bottom line, how much do you make on something? Bottom line. So then they want to hear what your mean is, what your standard deviation is. They say, what am I looking at? So here's we didn't do this one, right? Here's the scores for the California Police Officer Standards and Training Test. They're normally distributed. They have a mean of 50. Always just pull out your information and your standard deviation of 10. Okay. An agency, they told us it was normally distributed, so we know it follows our normal curve. So we know we can put this on our normal curve. So we're going to, this is easy, 60, 70, 80. Did we do this yesterday? Yeah. We did this one? Did we get through the whole thing?
Well, it's always good to repeat. I know that.
All right, we'll just go over this part. And then you're going to do the try it. We probably were up to you doing the try it one. So now they give this test and they say, well, for my police officers, I only want the best guys that did well on this. I don't want the guys that struggled on this police test, right? I want them to know what they're doing. So I'll only hire an applicant within the top 10% of their group. So now I got to tell them, what is the number that you're going to look for? The top 10% says, what do I have to do? Figure this out for myself? I need to figure out what is my cutoff score for this. So what we're looking for is, what is the lowest score that an applicant can earn and still be hired by this agency? Still be in the top 10%. So what we're looking for is the top 10% is up here somewhere. Because remember, this goes from 0 to 100. So the top 10% would put them at the 90th percentile. We got to find that X value. So since we're looking for that X value, we're going to use your formula, transform, to find your X value. Now I have the mean, I have the standard deviation, but I don't have a z-score that's associated with that top 10%. So how do I find that z-score? How do I find the z-score that's associated with the top 10%? There's a number of ways to do it. Yep, so how? You use inverse norm. What's your inverse norm? So how can I get there? Second, bears, inverse norm. What am I looking for? 10%? 0.9. So you're going to look up 0.9 because it's 90% to the left. And you're going to find me the z-score, 1.28. Now, what if I looked up 10%? Would I be okay to look up 10%? What's going to happen if I look up 10? It's going to be the opposite, but isn't it still going to be 1.28? Right? So it's still going to be 1.28. It's just going to be the negative part of it. So here's the deal. If you want to look up area to the left, this is 90%. If you want to look up 10% down here, because it's symmetric, you just have to remember when you look up your 10%, and this one's negative 1.28, this one will have to be positive 1.28, because your curve has symmetry. So you can do that either way. If it's better for you to look up 90, look up 90. So we plug this in, and now we can find the cutoff value. So we find your cutoff value to be 62.8. So now, when I'm looking through the scores, I need to find somebody that gets a 62.8 or higher. So let's talk about rounding for a second. Now my shading is over here, right? Somewhere over here, to the right. If I have to round to the nearest whole number, not counting your rounding rules, but looking at your chart, I need a score 1.1, so 1.28 is over here somewhere. This is the border of my 62.8. Think about it for a second. If I have to round and be within this 10%, am I going to round up or down? Look at the graph. If I want to round this to a whole number, regardless of what it is, if it's 62.1, 62.5, 62.8, where am I going to have to round this score into if I have to go to the nearest whole number? Don't I have to be in this area? If I round down, won't I be here to 62? Won't I be outside of that 10%? So remember when you asked me about rounding and I said as soon as we hit the shading with the X's, you'll see it makes a difference? This is where it makes a difference. If the test scores are in whole numbers, I don't want somebody with a 62. They didn't reach my 10% yet. So because I need them to be up in this area, I always have to round their score up, if in fact it said round to the nearest whole number. Now if I was the opposite way, and I wanted the lower 10%, then I would have to round down into this shaded area. Do you see the difference? You just got to keep track of where your shaded area goes. So we okay with that? So now I'm the person in charge here, and I start looking through all these, and I say, okay, it can't be lower than 62.8. 62.8 and higher is my 10%. So all I have to do is keep looking at the scores, kicking out the ones that don't mean anything to me. This whole thing didn't mean anything to me, but this is what I'm looking for. Give me the bottom line. What do I need to see? Okay? So now you're going to try the next one. And so either way, whatever one you got is fine with me. If you did the bottom 1%, you're down here. Because this is the bottom of your graph. I get that. Your z-score is exactly the same. And it doesn't make a difference in terms of finding your z-score, but it does make a difference in determining is it a positive or a negative. Like which end of the graph do you want to be on? Normally, we always go lowest to highest, and always highest means good, the best. Like terms of grades, weights, whatever it is we're looking at. That is where the more part is. But the problem with the braking distance, it has an opposite effect. So while the book says the bottom 1% here, I think the bottom 1% should be here, because this is the braking distance that I don't want.
I agree.
I don't want to step on my brakes and have it take 141 feet to stop versus 116 feet to stop. So whichever way you did it is fine with me. I mean, as long as you get the concept, find the 1%. I tend to think it goes on the other side, because to me, the top, I would think this would be your top 1%. These are the better brakes. If I was looking at somebody's standards, and I was looking at their brake pads or whatever I had to buy, I would look for the shortest braking distance. That would put me at the top. So, and I get that they did the bottom, and the book did this too. They took the bottom. But, so do you see where the predicament is? The 1% is still 1%, it's still 2.33. If you're on the left side, it's negative. If you're on the right side, it's positive. So I like this question because it gives us a challenge here. The z-score is the same. The setup is the same. The key is right here. Is it the negative or is it the positive? Do I want to place it at the left side? Do I want to place it at the right side? Right? So it gives you a little bit to think about. All right. And we'll do one more together. And again, we'll just take a look at this. And let's talk about this and see what we think about this. In a randomly selected sample of women ages 20 to 34, the mean cholesterol is 181 milligrams per deciliter, and the standard deviation 37.6. Is that milligram? Is that how you measure cholesterol? No science people here?
I guess so.
Okay, so now, assume that they are normally distributed. So we're going to, again, make a little chart here. Now, all right, so let's make a chart. And let's talk about this one as well. I must like be the rebel because I never agree with what they do. So here's your mean, 181. We're going to add 37.6. I'm big on putting the numbers out here, guys. I think it makes far more sense when you do. I know that one doesn't show up, but you're not going to need that one anyway. And then start at 181. Okay? All right, now, we're again looking for the bottom 1%. We want to find the total cholesterol that a woman could have and be in the bottom 1%. Now again, cholesterol, from what I know, means it shouldn't be very high. You should not want a high cholesterol. But I think at the same token here, you should also not want a very low cholesterol. So the bottom 1%, and the book does the bottom 1% again over here. I'm not sure, I don't understand the cholesterol readings that well, but I know where the average is, and I know like where my cholesterol is always a little on the high side. But I also think you can't be this low. I don't know if anybody does that in their science, but so the bottom 1% could be considered here. You also, however, can consider the bottom over here. If this in fact is good, then the bottom I think would be over there. So it's the kind of the same concept with the breaks. It's where you place this. Now, the key here too, they gave you their standard deviation with decimals, so your answer can have a decimal. The key here is the shading, where you're rounding to. You want to have to round into your shaded area. So if it's up here, you're always going to round up. If it's down here, then you want to round down to put me into the lower part. So the only thing that I wanted to make a point on is where your shading goes. So again, you want your mean. So we have two situations again. You're going to take your mean, and let's go with the bottom to be there. There's your z-score. We're in the 1%, so we have the same exact z-score and standard deviation. And I think they come up with 93.39. Now, if I had to round this, by law this goes down anyway, but I'd have to round down into my shaded area. So, depending on how they phrase this, the bottom 1%, the top 1%, just justify your answer. That's all that you have to do. If you say that the bottom part should be on the top because you shouldn't be a high cholesterol, I get it. Yes. I don't know. Probably not. I probably wouldn't take a point off. But I would like you to just be aware of where your shading goes, where your shading is.